Hello students, in the previous two lectures we have defined different double points and discussed different methods for finding the nature of double points. Now we'll solve problem based on that. Find the nature of origin as double point. This is a rational algebraic curve x to the 4 minus a x square y plus a x y square plus a square y square is 0. Now this rational curve passes to origin. So this method, this second method, general method is not applicable for the. This will become lengthy when you solve the if the rational algebraic curve passes to origin. So don't proceed by this method. Now I'm just comparing here. I'm just comparing here while solving problems in examination. We we discuss the nature by the the first method, not by the general method, particularly. So now let us write this curve in the fxy form. Fxy is equal to this is equal to the fx put the fxy is equal to this function x and y. We will discuss in two dimension. So now in order to find possible double points, we'll just differentiate fxy is to x, put that equal to 0, f is to y, put that equal to 0, put them equal to 0, and also find second derivative to f is second derivative of f is to x, second derivative of f is to y, and derivative of f with this to xy, second derivative of the xy or yx. Now in order to find the possible double points, put the first derivative of f is to x equal to 0 and derivative of x equal to 0, these two equations, solve these equations for x and y. So after solving these equation, we got the points, possible points, possible double points. They are 0 0 and some other point is equal to this, and x is equal to ay upon b, and from these equation y you can solve for x for x1 the complete result. Now after finding possible points, you substitute the points on the fx value 0 and they satisfy they will be the double points. So now in this case, only origin is the double point, which will satisfy the rational equation rational curve. Now we discuss the double point origin as the origin for the double point. Hence, this is the possible point. Hence, now we'll define the value of d. D is equal to positive f is to xy or xyx. Otherwise, with xy or yx whole square minus so f is to x, so f is to y. So f is to x, so f is to y. Now find the value at 0 0 and substitute here. If find this value at 0 0 and substitute, find the value. This is equal to 0. This is equal to 0, then you tell this origin is either correspond not or a conjugate. Now to decide whether correspond conjugate point. Now because this rational curve passes through origin, so this method become lengthy. So you can start from there here also. Because the rational curve passes through origin, therefore equation of the equating to 0, the lowest term, the tangent at the origin are given by a to 4, a square y square equal to 0, for this to 0, y equal to 0, y equal to 0, they are two constant terms, two constant tangents at the origin. Two tangents are real and constants at the origin, so the origin is either cast for a same discussion same here and same result we got. This one lengthy. This method we will apply this method only when the curve does not pass through it, right? Otherwise, this method is easier. Now, already we decide whether this occurs for a conjugate point. Now we study the nature of the origin, nature of a given curve near the origin. Since the equation of gradient are in the form versus 0, in order to study the nature behavior of the curve in the neighborhood of the origin, we have to neglect the terms of y whose power are more than 2. But equation equation first does not contain power more than 2 of y. So straightway solve it for y after making it in quadratic, making it quadratic in y. This make quadratic in y, solve it for y, simplified it, and bring this form. minus b plus 1 into b minus 4 is equal to 0. So now we discuss it further for the curve for in the neighborhood of the origin, this equation. Now this term will continue. For small value of x in the neighborhood of 0, left neighborhood to right neighborhood. This term x is very small, whether negative or positive. So it's very small, positive. So this will not change the behavior of this term. Very small, 0.0001 into the fixed number, this will be very small as compared to this negative, this will be negative. So this is the positive, this positive, very small positive number. If you multiply this positive positive, so this negative term, very small number added to this will, the behavior of this term will not change, will age a fixed number. So this will remain in the neighborhood of origin. This term under the root minus is minus 3 square minus 4ax will remain negative. Negative. Therefore, origin is a origin. The value of y is imaginary in the neighborhood of origin. The neighborhood of x is equal to 0. Therefore, this point origin is not a cusp but is a constant. Right? Similar again same problem. Now this is the constant is missing from here. So in the similar fashion we get this. Examine the nature of the origin as a cusp. Now this does rational does it passes the origin. So straight away find the equation of between zero the equation of the curve passes through the origin of the coordinate axis. Therefore, f is 0. The equation of tangent will be equal to 0. The lowest two terms in x. Lowest term is 4x minus 4x is equal to 0. So it implies for this to be 0, x is equal to 0, y is equal to 0. They are the two tangents. So they are real and distinct tangents. So the what will tangent? What is this tangent decide? Either the origin is a cusp or is a cusp or conjugate point. It's a node or conjugate point, not cusp. It's a node. This is either node or conjugate, not cusp. This is a node or conjugate point. Now to decide whether it's a node or conjugate point, uh, whether the neighborhood of point O lies on the curve of the given equation. First, we neglect the because we can neglect either x4 or y4. So after neglecting x4, we get the equation in x4 we got the equation x. Now for small value of y, small value of y, x is real for small value of y, either positive or negative. The root term is not there. So what does imply? The real branches curve passes the origin. So this origin is not a conjugate but is a right. Next problem. Show that the origin is a node or a cusp or a conjugate point. So the origin is a node conjugate point on the curve. Yes. Y is equal to ax square plus bx cube. Now, according to a positive negative or positive zero negative, right? Now again equation this is fxy. This is no constant term, and the lowest term is secondary term in x and y. Straight way, this passes to origin. So double origin can be double points. So origin we ask to origin only. So find the equation tangent at origin equal to 0. The lowest term in x and y is equal to a y square minus ax square is equal to 0. Y is equal to plus minus and root ax. So there are two tangents at origin. Now three possibilities arise if a is positive. If A is positive, then real tangents will be real. Equation implies if A is positive, equation implies that tangents are real distinct. So the origin will be either node or a conjugate point. Now to find real branches of the curve passes through the origin, neglect this equation is in terms of which? In terms of y. So we can find the through the origin, neglect the terms of y whose power are more than 2. General procedure. But in the problem, we don't have such term. So solve it for y. Again, y solve y. Now, a and b are fixed. If x is very small, we are discussing the origin. In the neighborhood of the origin, x is left or right. X is very small. Very small level find number is very small. A is positive, so this will be positive. So tangents will be y will be real. For x is real, y will be real. So two branches of the curve near origin exist. So this is not a complete one. Now if it is zero, this become the two tangents will become coincident. So the origin is at the cusp for the conjugate point. Again, we have to decide whether this is cusp for a conjugate point. Again, solve it for y. Y is equal to x cube, then a x cube. Now for this small value of x, small value of x, this will be, what will this? In the neighborhood of origin, y is real when when b and x have the same sign. X and the same sign. In sign will be b is positive, this is positive, this is negative, this is negative, then origin is a cusp. If they are opposite sign, this will be imaginary. Imaginary means this will be conjugate. Now, when a is negative, is less than 0, then this comes out to y is equal to plus minus and is negative, whatever value x may be, tangents at the origin are imaginary. Negative, right? Tangents are imaginary, so this is a originally complete. Now let us solve another problem or to discuss the nature of double point. Determine the position and nature of double point on the curve x cube minus y square minus 7x square plus 4y plus 15x minus 13 to 0. The equation of the given curve is f of x y is equal to, let f x is equal to x cube minus y square minus 7x square plus 4y plus 15x minus 13 to 0. When the origin of the coordinate axis does not lie on the given curve, then we have to solve the problem by this method. First step is we will find positive f is to x and positive is to second positive x, positive y, f is to y, second positive f is to y, and positive f is to xy or yx. Second order. Find them. Second step is find the possible double points. So to find the possible points, we put positive f is to x is equal to 0, positive f is to f is to y, f is to y 0. From these equation, we will obtain the 2 points ordered pair x y. If those order pair which satisfy the equation f of x is 0 are called double points. Now solve this equation. Positive f is to x is equal to 0, positive f is to 0. So this is a quadratic x and this is the mean y. So we got the value of y is equal to 2. And when you solve this equation, 14x, this is 14x, 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 this is equal to, we got by factorization, this we got equal to 45, and we got the value of x is equal to 3 and 5 by 3. So the order pair possible points are 3, 2, 5 by 3, and 2. Now we'll check whether they are with the double points. We'll substitute their values. We substitute if this order pair satisfy the equation f of x is 0, then they are double points. So put x is equal to 5 by 2 and y is equal to 2 in the f of x y. We'll find that this is not equal to 0. So 5 by 2 and 5 by 3 and 2 is not a double point. Now other point f of 2 3, this satisfies the f of x is equal to 0. So this is not double. This does not satisfy. This is not double point. Therefore, this satisfies the equation. So this is the only possible double point. So at this point 2 3, we find the value of d. D is equal to positive. Find the value of this d at the point 3 2. D is second positive f is to x y or y x minus second positive is x or second positive f is to y at this point. So at this point, we find the values. Find the values. Find second positive is to x at 2 3 2 and y is f setting the velocity to f is to f with this 2 mm, f with this 2 f with this to y setting the velocity to f is to y at 3 2 and setting the velocity to f is to xy at 3 2. Then substitute define the value d from this. D comes out to be 8. So 8 is greater than 0. The double point is a node or a conjugate point. Now to decide whether it is a node or conjugate point, we have to shift the origin to this point. We shifted the origin to this by the transfer test. X small x is equal to x plus h, y is equal to k. Now replace x by x by x capital X plus h, y with capital Y plus k, and substitute in the equation f x y. Simplify that, and we'll get equation on capital X and capital Y. Now this is the equation. This is the new equation in x and y. This transformed equation, and in which the second this is the equation which is passing through the origin of this lies at the point 3 and 2. Now the new origin. The new origin lies at the double on the double point. Therefore, the equation of tangents will be obtained. Equation equal to 0 the lowest term to obtain the equation of tangents at 1. So equation of tangents will be, or the second equation will be this is equal to y square minus y square plus 2x square is equal to 0. So y is equal to plus minus under 2x. Now equation of tangents are real and distinct. It's real and distinct. Real and distinct. So which verifies that new origin is a node or conjugate point. Similar case. What we have decided here is a node or conjugate point. Same thing, same conclusion will get from the equation of tangents. Real distinct. This is a node or conjugate. Now we have to decide whether it's a node or conjugate point. To verify whether the two branches of the curve passes to the new origin or not, we will solve the equation. Now this equation y will solve the equation for y by getting the higher powers of y more than 2 in equation. This is in the equation segment. So after solution, we got y is equal to plus minus x and x under root of x minus 2. So now this is equal to which gives real values of y if x is very close to 3, very close to x is positive or negative. New origin of this x is 3 2. This is 0 0 origin for that. So it will be for it's very close to 0 0. This will be negative. This will negative. This will be which gives real value of y for small values of x, positive or negative. Positive or negative. Small values. What is the value of 3? This is 3. 3 very close to 3 will be positive, and this will also positive, and this is very close to negative, left node of 3 or right node of 3. This is positive. So the real branch of the curve passes through the new origin at this. So this is a node. Thank you very much.